Today we're going to be talking about video analysis and how it can be used as an observational tool for biomechanics in clinical and athletic settings. In order to analyze performance and provide feedback, it's essential to correctly set up your video recording equipment and environment to ensure that you get the best recording possible. The first thing we'll look at is camera resolution. Camera resolution can be broken down into time resolution, pixel resolution, and spatial resolution. Time resolution is referred to as frame rate. Frame rate is the number of frames recorded by the camera every second. Your frame rate needs to be fast enough to capture the fastest part of the movement that you're examining. For sport analysis, this may be anywhere from 120 frames per second to over 1,000 frames per second, while clinical analysis may only need 30 to 60 frames per second. If the frame rate is set too low, you'll miss important information that occurs between frames. You might also experience something called motion blur, which is where the object isn't visible or has a blurry trail behind it. If this occurs, you're missing critical information regarding the skill. This is why it's important to set the frame rate fast enough so that you're able to capture all of the key features of the skill being analyzed. Pixel resolution is the number of horizontal and vertical pixels recorded and indicates the size of the image. It's responsible for image clarity, with higher pixel counts resulting in more detailed images and lower pixel counts ending up with blurry images with fuzzy details. The standard resolution that you'll be recording at is either 1080p or 1440p, but newer cameras are able to record at up to 4K. Time resolution and pixel resolution are inversely related, meaning there's a trade-off between camera speed and image clarity. This means we have to make a decision between how fast to capture and how much detail we require. The faster we want to collect, the lower the resolution will be. There are exceptions to this, such as the phantom cameras that can record 1080p at 12,500 frames per second, but this comes at extremely high cost, both for the camera and to provide sufficient storage for the video. Extreme examples of frame rate can be seen in this video, which is the first to record light moving through an object at over 10 trillion frames per second. To get an idea of how fast that is, you can check out this other video. We can clearly see that in order to have good resolution for recording movements, you need to set the frame rate as high as possible to avoid motion blur, while maintaining adequate pixel resolution in order to record sufficient detail in the image. Spatial resolution is simply the size of each pixel. So a camera with a larger sensor is going to have higher spatial resolution than a camera with a smaller sensor where the same number of pixels are crammed into a smaller space. Now let's talk about zoom. No, not the video chat we're all stuck using these days. We're talking about camera zoom. Ideally, you don't want to use any zoom with your camera. If zoom is required, then it's best to use optical zoom. This is because optical zoom uses a change in the physical lens to amplify the image. This means it changes the actual lens shape so that you have a smaller area with the same number of pixels. Try to avoid using digital zoom because this type of zoom focuses in on specific pixels, meaning you'll have the same size of image but with a lower resolution. The next thing we need to consider is camera placement. Setting up your camera for recording videos requires a little bit of care and planning. You need to ensure that the camera is an appropriate distance away from the performer so that you can see the entire activity within the frame, but are close enough to clearly see the details of the performance. If the camera's placed too close, you can miss critical information of the skill. If it's placed too far away, then you'll lose resolution. Camera height is also important and should be set around the midpoint of where the action is. This does not necessarily mean the midline of the performer, but rather the movement being performed. For example, if we're videotaping a tennis serve, we want to capture the entire skill, including contact of the racket with the ball, so we may have to set the camera height higher than the performer's midline in order to view the racket throughout the movement. Cameras should be placed at the same height, if possible, when viewing from multiple angles. Additionally, we need to take into consideration whether the cameras are going to be moving. Ideally, you want to have a stationary camera, which can easily be achieved by using a tripod. But if recording the skill requires camera movement, you need to have a way of stabilizing the camera so that your image isn't shaky. Video can be stabilized by using a gimbal attachment, or in some cases the camera may have built-in stabilization, though this can introduce movement artifacts. When you're preparing for your recording, make sure that you set up the cameras so that the critical aspects of the skill are in the center of the field of view. For example, if you're videotaping a long jump and you want to observe the run-up, takeoff, and landing, then you might need to use separate cameras for each stage of the performance. If you only had one camera set up to view the entire performance, you'd be sacrificing scale and resolution for the sake of seeing the overall picture. In sports where the overall picture is as important as the discrete skill, such as team sports, then it's a good idea to have a camera placed to capture as much of the action as possible. If you'll be repeating your analysis in different locations or on multiple occasions, then you need to make a record of where the cameras are placed relative to the performer so that you can maintain consistency and allow for accurate comparisons between trials or athletes. To do this, record the height of the camera, the distance the camera is away from the participant, and ensure that the camera is facing perpendicular to your intended plane of observation. If you want to take measurements from your video, you need to have a reference measurement in your image so that you can convert pixels to real-world measurements. Next, you'll need to make sure that the performer is wearing appropriate clothing, if possible, and use joint markers if you want to track movements occurring at specific joints accurately. This requires the performer to wear tight, dark clothing with contrasting light-colored markers. The markers should have concentric rings to reduce the area being tracked. Avoid using crosses because they don't work quite as well. The markers should be placed on anatomical landmarks surrounding the joints being analyzed. This allows for consistent marker placement between performers and multiple recording sessions. The markers can be used for visual observation as well as automatic tracking by video software such as Kinovia. We also need to make sure that there's adequate lighting while recording. Always have the participant lit in the foreground instead of the background, meaning you want the light facing the participant from the same direction as the camera, preferably at a slight angle to prevent washing out the image. If you follow the guidelines we've covered, you should be able to record high-quality video to aid in your qualitative and quantitative biomechanical analysis of sport performance.